Hello everyone, this is the 21st problem from IOQM 2023. Says that for each n belongs to natural numbers, consider non-negative integer valued functions f on 1 to n satisfying fi is greater than equal to fj if I is greater than j, and summation of I equal to 1 to n I plus f of I equal to 2023. Choose n such that summation of I equal to 1 to n fi is the least. How many functions exist in such a case? So basically, this first statement means that the function f is from the set 1 to n to the set of non-negative real integer values. So basically, this is the set, this is the function, and we are given that summation of I equal to 1 to n I plus f of I equal to 2023, and we have to choose n such that summation of I equal to 1 to n fi is least. So notice that the above expression can be written like this with separated two parts equal to 2023, and we need to minimize this part. So if the first expression is minimum, this is first and this is second. If the first expression is minimum, then this expression should be maximum. Also, we should consider the fact that fi is positive for all I. So we need to make this as large as possible, but still less than 2023, so that summation of fi would take up the rest of the numbers. So notice that second is given as summation of I equal to 1 to n I is given as n into n plus 1 by 2. So the first expression would be given as 2023 minus n into n plus 1 by 2 equal to summation of I equal to 1 to n f of I. And to minimize this, we have to make sure that n into n plus 1 by 2 is less than 2023 but nearest to. And a simple calculation shows that n equal to 63 gives this number, because if we calculate n into n plus 1 by 2 for 63, so 63 into 32, and this is 21, 6, 2016. So this is the nearest to the number 2023. So for summation of fi to be least, n equal to 63, and in such a case, summation of I equal to 1 to n fi is basically equal to 2023 minus 2016. So this is equal to 7. So summation of fi, and we get n equal to 63, so we write 63 here. So summation of fi is 7, and because fi is an increasing function, so basically if we consider the set f1, f2 up to f of 63, so written in this manner, this set consists of only increasing elements, this collection. So we need to find a way to distribute 7 among, we basically know that f of 1 plus f of 2, f of 63 equal to 7. So we need to distribute 7 in such a way that it is an increasing sequence, and secondly, the numbers are non-negative integers. So notice that each such function, we need to find the total number of functions, and each such function correspond to a partition of the number 7. What I mean by partition is that 7 is written as some sum of some elements. So suppose we write 7 is 6 plus 1, or we write 7 equal to 2 plus 3 plus 1 plus 1. So each partition corresponds to one such function, because suppose we take the first partition. So this would correspond to a function where we basically put the largest number in the like the largest value in the partition to the largest number here. So 6 would go to 63, 1 would go to 62, and rest of the numbers are 0. So suppose we write 7 equal to a1 plus a2, suppose like this. What we do is we put the largest number in f of 63, the second largest in f of 62, and so on. We keep on doing this, and in such a manner we can easily show that each partition corresponds to exactly one function. So we basically need to find the number of partitions of the number 7, and that would be the answer. So let us try to find the number of partitions. So suppose we write 7 equal to 7. This is one partition. 6 plus 1. This is another partition. 5 plus 2 is another partition. 5 plus 1 plus 1 is another partition. 4 plus 3 is another partition. 4 plus 2 plus 1 is another partition. 4 plus 1 plus 1 plus 1 is another partition. 3 plus 2 plus 2 is another partition. 3 plus 2 plus 1 plus 1 is another partition. 3 plus 1 plus 1 plus 1 plus 1. Then 2 plus 2 plus 2 plus 1. 2 plus 2 plus 1 plus 1 plus 1. 2 plus 1 plus 1 plus 1 plus 1 plus 1. And the last partition is 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. Once again, I would say that suppose we consider a random partition say this. So in this partition, this set is this f wala set is f of 63 equal to 4, f of 62 equal to 2, f of 61 equal to 1, and rest of the f's are 0. So these are the total number of functions in such a case, and you can count it up. It comes out to be 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Wait, I think I have missed another one. Yeah, so I had missed another partition, 3 plus 3 plus 1. So total you can count there are total of 15 partitions. So 15 is the answer to our problem.